Hello there, I am Jake, and this evening I'm going to be running over the severe weather risk that is predicted for tomorrow across the Northeast United States. So, this is a little mosaic of what's going on in the world of weather right now. Some thunderstorms in the Virginia and North Carolina area from the slight risk there today. Those are moving off to the east tonight as that severe weather event wraps up there. And we'll be talking about what will be going down here tomorrow. So, SPC here with a level 2 out of 5 slight risk across the Northeast here from the Scranton up to Portland areas. So pretty solid region with a good amount of population, over 27,000 in a slight risk tomorrow. And I'm going to be focusing on this slight risk here, not this one out here in the Dakotas, to talk about today. So in terms of the SPC's thinking for this event, not really much in the way of tornadoes. They're thinking less than 2% all areas. For winds, 15% winds. That's the second lowest there, but still 15% showing that there is some confidence that there is going to be some damaging straight line winds on tap tomorrow across this area. And hail here, 5%, that's the lowest, but still a hail risk present nonetheless. So, Northeast, not really thought of as an area with too much severe weather, but does get it occasionally, and tomorrow seems to be one of those instances. So, let's dive into what could be going on. So, mentioned there were some showers ongoing in Ohio right now, West Virginia too, with this showery activity out here. And what's causing that is I'm going to bring up the maps here. What's causing that is this little shortwave trough that you could see at 500 millibars here. It's not very noticeable. It was more noticeable on the 12Z upper air chart. In fact, let me see if it's visible at 700 millibars. Yeah, a bit more visible at 700 millibars. So that little kink in the isobars there, pretty much indicative of some ascent in that region. You have this little short wave gliding around a larger, much larger trough here. So you have this big, longer wave. It's a closed low up here or something. And this little short wave that's causing this showery activity you got rising motion there, and boom, you have some showers out there. And what that's going to do, let's turn over to some mob data here. I'm going to go on the NAM 500 millibars. So I'm going to initialize this. 0Z monorun came out. So with that little shortwave, there's that shortwave there. It's going to do is that's going to glide off to the east here. Very zonal flow. Not much north or southerly component to this flow. It's all straight out of the west here. A little bit dip there, but in general, the flow regime is zonal. And you can see this little shortwave, not very noticeable, but it does kind of glide through the southern northeast area around here in the mornings, this 12Z, for going off, and this is the rest of the day at 500 millibars. So this shortwave here is probably going to bring some of that showery activity across the region down here. The sense that it has probably going to be cloudy as well. There's a warm front coming through. And, and we're also going to take a look at the height falls that occur from this long wave trough. So let's pay attention to the heights across the region. So the NAM is saying we're about at, let's look at Connecticut here, 582 decameters. And as the day progresses, can really see those lower heights coming in from the north. And that's pretty good for storms because you generally want to see heights fall as the day goes along, as that trough with this big belt of flow here comes through. In terms of that belt of flow, you kind of get more of a glancing blow from the ascent that it has. I mean, these jet streaks here with these really high winds compared to winds down here, this big streak of higher winds into the 60 knot region. Generally has a lot of ascent associated with it, especially in some of the exit and entrance regions. We're not really going to be seeing that too much, but we are going to see some large scale ascent because of those height falls coming in. So looking at southern New Hampshire and Vermont here, starting early in the day, 579. As the day goes along, we're at 576. So that is a that's a good thing for storms in the region. As I said, you have that short wave coming through early in the morning, but that longer wave one coming down and causing some of that rising motion. Let's take a look at the GFS here, see if it paints a similar picture. And oh, it hasn't come out yet. That's okay. Going to start at 15Z, kind of get a little bit of that shortwave action down here. Could cause some cloudiness and showeriness, maybe even a little fog too, as that warm front moves up north, but I'll talk about that in a second. So 12Z, you have that, and in general, the picture is pretty much the same. You have these height falls that occur as this larger trough moves in here with that larger belt of flow coming in as well. And I'm going to go to the Euro now. Go plus up only. And that's the same thing, except really seeing much of those height falls. You have that zonal flow, but Euro not really seeing much of that activity. I was looking at the wrong day. Sorry about that. And 12Z here. So starting out with 582 and okay, pretty much the same thing. Pretty broad region of height falls with that short wave coming in the morning. I was looking at this thing, it was Sunday. Apologies for that. But yeah, so the synoptic pattern pretty much kind of set in stone. All the models agreeing with that short wave coming through, maybe giving some cloudiness and showers as the day starts. And then as the day progresses, you see this broad ascent kind of looming over the region. Not really any areas of focus. I mean, on some of these big severe weather days, you see these shortwave troughs going back to this guy. You see this little kink here. You see these shortwave troughs come in later in the day that really kick up thunderstorm activity. We're not really going to see that. I'm not really seeing many short waves embedded in the flow here that could serve that purpose. So kind of going along here. So something at 12Z, and not really much. I think a lot of these little short waves here are convectively induced potentially. So not really many short waves that you can pick out. Some kinks here and there, but nothing really major aside from that short wave that comes through in the morning. So that's something to note. So let's take a look at some frontal boundaries here. So this is the observed data at 02Z. And what you can see here is you can see some broad cyclonic flow around the Great Lakes area. That low pressure system is off somewhere, appears to be here-ish in Lake Michigan territory. So I haven't really done any hand analysis, but if I had to guess where the surface low was, it would probably be somewhere in this region where that broad cyclonic flow is ongoing and a frontal boundary draped somewhere in here. You could see a bit of a wind shift here. Winds out of the south on the Delmarva Peninsula here. And winds are kind of out of the east here near the Philadelphia, Wilmington metro area there. So that front probably extending north here. It's been quasi-stationary all day. Hasn't really been moving all that much, but that's the warm front that's going to be starting to lift northward overnight and eventually end up somewhere here when the severe weather risk gets going. And out here in Wisconsin, you can see evidence of a cold front, some kind of frontal boundary here with this pretty noticeable wind shift. You see winds out of the southwest down here, and then winds firmly out of the north up here. I'm doing this at night, so the temperature difference might not be too noticeable, but there is a cold front extending in this area here and a warm front extending down here with a low connecting them up here. And what's going to happen is these features are going to move off to the east here this way. So I would probably say the low is going to wind up somewhere in here, this area tomorrow afternoon, and the warm front's going to lift northward with that. And that cold front is going to be draped across the Adirondack Mountains, Green Mountains, somewhere out here. I'm going to do a bit more analysis than just speculation in a moment here, but that cold front going to be draped pretty east to west, and I'll talk about what that means in a second. But that's the general idea of what the frontal boundaries are going to do. Let's move on to some temperature things here. So let's start with the NAM here. Let's get the most recent model run in. Now that it's in, I was looking at some of this stuff earlier. So let's take a peek here at what the NAM has at 12Z. So 12Z, NAM has that warm front coming through, and it's got some low 70s, upper 60s temperatures across the region here. Now, NAM generally has a bit of a cool bias, so but with that shortwave coming through, that might cause some precipitation in the region. I'm kind of curious to see if that's actually holds up here. And it's the GFS that's actually slightly cooler in the morning here. You still see those 70s across the Long Island Sound into Connecticut, but NAM has them extending a bit further, and the Catskills here a little bit cooler as well. So that's something interesting. I'm curious to see if that verifies in the morning. For pretty warm across the area. It's already having some daytime heating occur up here, probably. But I think the general trend is that we're going to be seeing the low 70s across the region here. And let's take a look at what dew point has to do. Very moist morning, I will say that. And I think that's probably going to have to do from the cooling, some of that precipitation might do, nocturnal cooling, and that from that short wave coming through. And what's going to happen is that low out here is going to bring in some pretty solid moisture out of the Atlantic. I mean, it could be a pretty muggy morning across the whole region here from Philly up to Portland. I mean, it's just going to be like high dew points compared to the temperatures. I mean, NAM is depicting, what was that? What, 72 over 70 near like Waterbury. That's going to be a pretty gross morning if that verifies. What does the GFS say? GFS, a little bit more reserved on the moisture. I think the NAM might be overdoing it slightly, though. I will say with that short wave coming through that will shroud this area in cloud cover, I wouldn't be surprised if the some of the more bullish moisture returns might might come to fruition. I don't think it'll be nearly this crazy, but I guess we'll see with some of those showery activity that might happen. It might keep the mixing at bay. And by mixing, what I mean is what happens is when the sun comes out you see drier, more well-mixed air come down to the surface because of convective overturning. It gets hot, hot air rises, that cooler, drier air comes back down. And what you see is that those dew points can sometimes lower, but with some cloud cover from that short wave, that might not be the case. So I do think moisture will be in abundance here. NAM already has the 70 contour at the Connecticut, Massachusetts border here, as the RAP say. RAP with a pretty similar picture there, and her known to overmix some dew points, but I mean you could see it's still pretty solidly around Hartford there. That 70 contour at that same latitude there. So moving on a little bit, you can see that the HER doesn't really do too much with the moisture, though I don't usually like to look at the HER for moisture all too much. And you can see the NAM pretty pretty sure that you can see some convection ongoing, doesn't really move the 70 contour all too much. So that's worth noting. And GFS mixing out quite a lot. And I think it's quite interesting. This is going down, wow, into the low 60s by 18Z. And I'm gonna guess that's because once the clouds move out, again, that mixing I told you about, where you see the sun start to shine and drier air gets mixed down to the surface, potentially that could lower dew points, but I don't know if it's going to be that extreme. I mean, in 3 hours, it goes from low 70s in Connecticut all the way down to low 60s. I'm not so confident that will happen because, again, with that cloud cover, that might linger for a little bit before some breaks in the clouds start to happen. It'll be most likely a cloudy morning across the region, at least early in the morning. And GFS seems to, I'd have to guess, it's thinking that there's going to be quite a lot of mixing from the sun. I mean, it is going to be quite hot throughout the day. Going back to temperature here. Yeah, again, usually runs a little cool, but you see gets up into the 80s here, close to the coast, a little bit cooler up here, but that's that cold front coming through. GFS, similar story, getting into the getting into the low 80s, actually a little bit cooler here, but you can see the hottest temperatures coming in from the south here, that warm front, winds out of the south there. Or similar thing, pretty warm here, getting into the high 80s in some areas there. And you can kind of see where that cold front is now with her pretty clearly. It depicts a very striking cold front here. I wonder if that could be topographically induced, potentially. But hers placement, you got the warm front here, pushing that air north, and then you have the cold front draped around here somewhere, and see the convection start to be introduced there as well. So I don't think there's going to be any shortage of surface concerns here. I mean, we're going to get into the high 80s, maybe even 90s in some local areas. You're going to see pretty solid moisture returns on the day. I mean, even some of the with more extremely mixed models like GFS. I mean, this is still low 60s dew points. You could still get storms with that, but yeah, I really am not sold that we're going to see this pocket of much less moist air coming through. I think those clouds and showers early in the day are really going to help keep that moisture safe from too much convective influence here. So I think there is going to be a pretty solid parameter space in terms of the surface here in the Northeast. So going back to temperature, her pretty shows that pretty striking front there. That's going to cause thunderstorms. And you can kind of see it retains that zonal orientation there. So that zonal being west to east in this case. Pretty zonal, a little bit of a north-south split, but that cold front is going to be pretty north to, or sorry, west to east. And I think that might cause a little bit of concern if you want to see more isolated thunderstorm activity. So I'm going to show you something here. So let's say we have a cold front. We got two scenarios. Cold front runs, say, east to west, or excuse me, west to east. And the cold front runs, say, north to south. So two different scenarios. And let's say the mean wind in the atmosphere or the deep layer shear to be more exact, two different things, run from, they point this way essentially. So remember earlier, you see winds are generally out of the west here, and say we have winds blowing kind of softly down below and then strongly this way up high, which is what we have here. You have deep layer shear that looks like this. So that's going to dictate a lot of things. Generally, your deep layer shear and mean wind vectors are similar-ish, I would say, but they govern a lot of things. They govern how storms move, they govern how storms orient themselves, and those are pretty important, especially in relation to the initiating boundary. So cold fronts, they have a lot of ascent in them, air rises that can help storms form. So let's say they produce storms here. So what's going to happen in this scenario down here? Let's say the storms form. What's going to happen is that they're going to develop and kind of tilt this way because of that shear vector pointing it pointing the storm away here. And it's also going to move it off of the boundary here. So these storms are literally going to push away as such here. So they're going to move out of that zone of ascent, but they're also going to stay isolated from one another. It's not like this one is going to ram into this one, unless you have a storm split, of course, but that's a topic for another time. But Storm's going to move off that boundary there and kind of stay isolated. These are classic supercells that you think of if you have the right deep layer shear conditions, of course, but they're going to stay isolated from one another. They're not going to ram into each other in this vastly oversimplified scenario. Meanwhile, up here, a scenario that closely resembles tomorrow, you have storms that form, but they're just going to run into each other. They're going to move right along into each other. And not only that, cold fronts generally have stronger forcing. They kick up a lot of air, a lot of ascent in that region. So strongly forced, you get a lot of convective coverage along the front, so lots of updrafts going up. And in general, because the deep layer shear vector is going to be oriented kind of parallel to that front, I'll show you something that illustrates that point a bit better. Because of that, storms they're going to cluster up and form into potentially Boeing segments or just a big general clustery mess. But I haven't looked at how much the deep layer shear is. So if I come here, so this is most unstable cape and shear on the NAM. So in general, that front is going to be oriented somewhat like this, if I had to guess. And as the day goes, kind of like this. Deep layer shear vectors here, and bulk wind difference, they pull off the boundary slightly, but there's a very large parallel component to it. And given how the front is going to be moving pretty rapidly throughout the day, I kind of see a more linear clustery mode developing with these storms here. So kind of like what I said, updrafts, they're going to have a tendency to run into each other. Obviously, they're not perfectly parallel. There's going to be some tilt to this trough, and it's not going to be just out of the west, the deep layer shear vector. But in general, I think this is going to dictate how the storms go rather than this scenario down here. So that's going to help. So that's why I think tomorrow generally strikes me as a more wind-driven day because you're going to get these clusters of storms that will produce downdrafts and straight line wind damage rather than a supercell that could produce a tornado and such. And I that's why I agree with the Storm Prediction Center kind of outlining wind as the main hazard. Hail, I'm not seeing too much in the way of hail producing updrafts here. I mean, we'll take a look at some soundings in a moment, but yeah, let's look at some soundings. So let's go between Springfield and Boston here. Let's see what we got. So this is a NAM sounding at what time is it? 21 C. So afternoon here. Okay, so pretty solid, very unidirectional photograph here, which does make me think potentially that generally favors hail. Not a ton of low-level shear, so that's a more wind and hail photograph there. Have 847 decape for downdraft potential, a bit of an inverted V sounding here. So definitely makes me lean wind a little bit, wind and hail. Not, I just don't think there's enough low level shear there for tornadoes to occur. Pretty solid cape profile though for this time of year, though it is summer, I should say. Yeah, that's a pretty solid severe weather sounding. If the NAM is 100% right and this happens, that's a pretty solid for winds. Also noticing pretty high PWatt values too. So these storms are going to dump some rain, pretty much precipitable PWatt precipitable water. How much rain can you dump? 1.69, that's kind of starting to get up there a little bit, though it's not overly high. So that kind of lends credence to the idea that this has more wind potential rather than hail potential and tornado potential. You have these downdrafts coming down that rain. So Let's pull a similar sounding from the GFS. Let's see, what's that there? Just to get another idea. GFS, not very high on the cape values, I must say. I don't usually use the GFS too much for this kind of stuff. Yeah, I'm not really sure if I buy that sounding there. GFS, not really great with this kind of stuff, though it also has those high PWatt values too, which are interesting. I'm really not sure what's going on here. I guess it's having the storms, but let's move on here. Let's see what the rap has to say here. Sounding from a similar region. Wait for that to load. Pretty similar picture, straight photograph, not a ton of low-level shear, good for hail in general. And yeah, pretty decently moist profile here. It doesn't have as much downdraft cape, but I'll look at PWatt now. I'm forgetting where it is here. Precipitable water. Okay, pretty high-ish values here. Generally, usually see to high values like this. Interesting. Okay, so some of this might be convectively induced with picking up the updrafts with rain and such, but I think the PWatt values a bit higher than I expected here. Like, so let's go in southern New Hampshire here, and pretty very crazy Cape profile, but very moist profile overall, I gotta say. So I think that definitely lends credence to the idea that it's going to be a more wind wind driven event with these decently strong downdrafts, which kind of hurts the tornado chances as well. I think downdrafts are going to be dominant in this event. So once those cold pools from the downdrafts merge pretty fast, I imagine you're going to get a bit of a clustery mode. And as for hail, while the photographs for hail, I would say look pretty solid. I must say, going back to what I said earlier about that short wave, I mean, in this region, you're going to have height falls. All right. You have a cold front coming through, that's good for forcing. I'm not concerned about storms forming, at least right now. The problem is that I haven't really seen anything that makes me think there's going to be really widespread, robust updrafts with this. I mean, if you cherry pick some pretty high Cape soundings, I'm sure you could find something good. But in terms of the overall synoptics, I'm not really seeing much that makes me think you're going to get widespread strong updrafts that can lead to widespread hail. So I guess if you even go in the highest cape, you see pretty low levels of free convection here. So even though, well, it's a pretty tall updraft, which is good for hail, not much low level shear, you have a lot of cape down here below your hail growth zone, kind of the freezing level where hail can start forming. It's going to shoot possible embryos just up too fast out. And again, tall updraft, straight photograph, I do think you could see some hail, but I don't really see much in the way of the parameter space or the synoptics that make me say, okay, we're going to get widespread hail activity. Again, in some areas, maybe with some topographical influence, you could see some hail with some of the stronger updrafts, but again, I just don't think it's there for widespread hail, though I wouldn't be surprised if we do see some reports, because Cape values with the, warm, moist surface, it's going to be there's going to be some solid instability across the board here. But again, if that shortwave was coming through, I feel like I'd be more confident in saying, okay, yeah, there's going to be some powerful updraft. I'm just not seeing much in the way that makes me think that there's going to be quite strong updraft. Cold front's going to kind of bulldozer everything as this system comes along here. So let's see here. Let's go to the href here. First of all, I want to see the cloud cover. I was looking at this earlier. Let's see what happens here as the day goes along. Yeah, you see that cloud cover. Whoops. See that cloud cover come in pretty early in the morning before it kind of starts to clear off, and the morning and the afternoon, and you'll have kind of sporadic breaks in the clouds that will allow the ground to heat up, build up that instability for eventually moving off. So let's just cheat here and take a look. It's the last thing I like to look at here. Northeast. Let's just see what the href paints for us here. Gonna see that morning stuff moving through. Just picking up that before. Yeah, you kind of got this clustery mess moving through this area here. So cold front sagging through. It even has some stuff initiating up there along frontal boundary. So once that once those clouds move out and you get some convection, and those dew points will, I would imagine, be pretty unsoiled because of the early cloud cover. Kind of start to see the storms finally develop and move through. Pretty linear action over here. There. So let's take a look. Let's look at updrafts here. I'm not really too confident that you're going to get these crazy strong updrafts that can make hail. So yeah, not really, nothing really striking about any of these updrafts I'm seeing. And not really potential for much strong updrafts. HRF seems to bullseye it down in southern New Hampshire here for strongest updrafts, but yeah, I just don't see the potential for widespread strong updrafts. A few of them I could definitely see. I could see some of those producing hail, but again, not very strong in that way. So what else could we look at here? I would say let's look at wind speed here. See if there's anything interesting to note there. I think wind could be pretty widespread. And let's see what HRF depicts. Interesting. Not really too much in the way of damaging wind here. This is probability over 30 knots here, and doesn't really have all that much in the way of widespread wind here. So something interesting to think about here. This is only one tool to use, and it's just a confirmation. I'm not really sure I buy the lack of too much wind here. I'm curious of the more recent run. Okay, it's not really out yet. So HRF not too confident in widespread winds across the region. I'm interested to see what this 0Z run says. Again, I'm willing to say that I think that there's going to be some pretty solid winds with this system here. Nothing crazy, but I do think that some of the model soundings in the parameter space does support a kind of a clustery line extending across that cold front, and we could produce some wind in this area here tomorrow. Question is, how far south could it extend? I think that the best instability values seems to be up here, as could be some cooler ocean air coming in from the south here that might dampen a little bit of that daytime heating. So more inland areas up here I could see having the most robust instability. So I would say this area here, even up to maybe even up to Portland, possibly, see is the strongest storms. But with that cold front coming through, again, cold fronts, they kind of act like bulldozers. With that pretty nice air mass underneath, I wouldn't be surprised. I do think that convection can extend down here. So yeah, that's my forecast discussion for tomorrow across the Northeast. I'm trying to think of anything else that I could talk about. This is just kind of an off the cuff sort of kind of can't really sleep at night. Let's talk about the weather kind of thing. So I'm interested to see how tomorrow plays out. Really, I don't think of anything else I'm missing for the moment. I could go further in depth, but I'm pretty tired right now. I'm recording this kind of late at night. So, all right. Anyone watching this in this area, hope you stay safe tomorrow. And yeah, that's about all I have to say. Thank you very much.